Here's our fifth example on the disk method in our solids of revolution series. Our equation is y equals x minus 3 quantity squared plus 2. We have a boundary of the y-axis, a boundary of y equals 2, and we want to revolve about the y-axis. So I put the original function in my calculator. I want to see what that graph looks like. I see this here. I'm going to quickly draw a crude rendering of this. As I draw the rendering of it, I have this parabola that's in the first quadrant. And I know that I am given a boundary of y equals 2. So y equal 2 happens to be right here, and the y-axis. So this is the region that they want me to revolve, but they want me to revolve it about the y-axis, which means that it would produce this upside down tornado shape, almost like a Hershey's Kiss shape is what that is. Because it's being revolved about the y-axis, I know everything has to be in terms of y. So this isn't going to cut it for me. I'm going to have to solve this for x, so everything's in terms of y. Before I do that though, I think I need to find where this point is here, because when I do the y values, I know I'll start at 2, but then I have to know where to end. So I need to find that point of intersection. And one simple way of doing that, I'm going to go second calc, and I just want to figure out what the value is at x equals 0. It tells me that my function has a value of 11. So in other words, this point here is 0, 11. And since that's 0, 11, it allows me to start to find my volume by saying, let's do an integral from y equals 2, that's the lowest value, all the way up to that y equals 11, the highest value in this region. So y equals 2 to y equals 11. Then I have to figure out what this function would be, because I'm talking about a radius that's measuring from the y-axis out. I have to solve this. I'll do that off to the side here. I'm going to start by moving my 2 over. I get y minus 2 is equal to x minus 3 quantity squared. Well, I can root both sides. As I root both sides, I get the square root of y minus 2 is equal to x minus 3. Now technically this is plus or minus, so I have to figure out which one I'm working with. This would be the positive side over here, so this is the negative. I must be working with the negative side of the parabola. So that would be this side here. And then I'm going to bring that 3 over. As I bring the 3 over, I could write this as 3 minus rad y minus 2 equaling x. If you're wondering how I know whether I have positive or negative, I'm just putting a line here. This is the positive side of the parabola, this is the negative side of the parabola. That's how I know I have the negative. Now when I go to my integral, I'm going to say the volume is equal to y equal 2 to y equal 11 for pi, and then I have to take that function and square it. So it'll be 3 minus radical y minus 2 quantity squared dy. And when I put this into my calculator, remember, it's just going to be a representation of the volume, but it's not going to look anything like this picture. And in fact, the volume is going to be done off the x-axis because I can't put y values in here. So I'll say pi parenthesis 3 minus the square root of y minus 2, which has to be x minus 2. And then I can get out of all of that function, and I'm going to square the whole thing. Then I can do my second calc, go to option 7, And I need this to go from 2 to 11. 2 to 11. Now, the reason why this gave me an error on my calculator, my window wasn't big enough. It's an easy fix. I just make that X value go up to like 15. I had to make sure that I could go through that entire value. With the TI-89, it wouldn't matter because you would type all this in as an integral and it doesn't care, it doesn't refine itself or define itself by that window. You could do whatever value you wanted. So let me try this again. I'll go to my graph. Once again, I'm going to do second calc, option 7, do that integral, and I need to start at 2 and end at 11. And that gives me a value here. It tells me that my volume would equal 42.411 units cubed. 42.411 units cubed. I think that should be good enough. You should have a pretty good idea of how to do volumes considering the disk method. So solids of revolution using the disk method. You have 5 examples to look off of, and then I'll be sending the worksheet.